Question 14. Part A. Given that 2 sine x minus 60 is equal to cos x minus 30, show that tan x is equal to 3 root 3. So we're going to be using our compound angle formulas for this question here. So we're going to go to our formula booklet, and using the formulas inside our formula booklet, we can see that 2 sine x minus 60 can be written as 2 sine x cos 60 minus 2 cos x sine 60. We can look again for the formula for our cos x minus 30, and we will see cos x minus 30 can be written as cos x cos 30 plus sine x sine 30. Now if these two things are equal to one another, we can write the following. And now we should know our actual values for cos 60 and sine 60 and cos 30 and sine 30. If we don't know them off by heart, we can use a calculator to find out those exact values. But cos 60 is a half, so 2 times a half gives us sine x. Sine 60 is root 3 over 2, so that's root 3 cos x. And that's equal to cos 30 is the same as sine 60, so root 3 over 2, plus sine 30, a half sine x. If we add the root 3 cos x to both sides and subtract half sine x from each side, we get that half sine x is equal to 3 root 3 over 2 cos x, which if we multiply both sides by 2 and then divide through by cos, we get tan x is equal to 3 root 3, which is what we wanted to show. Part B, hence or otherwise solve for theta between 0 and 180. 2 sine 2 theta is equal to cos 2 theta plus 30, giving your answers to one decimal place. In order to do this, we want to try and find a substitution so we can use the simplified expression we found in Part A. Now in Part A we had 2 lots of sine x minus 60. Now we've got 2 lots of sine 2 theta, and so if we use the substitution 2 theta is equal to x minus 60, we can then use the simplified expression in Part B. Rearranging by adding the 60, we've got that x is equal to 2 theta plus 60. This allows us to write that tan of 2 theta plus 60 is equal to 3 root 3. Now since we have 2 theta plus 60, the next thing we need to do is change our range. So we're solving between 0 and 180. In order to change the range for this 2 theta plus 60, we do 2 times 0 plus 60 to the 0 here, and we do 2 times 180 plus 60 to the 180. So our 2 theta plus 60 is going to be in the range 60 to 420. It's now a good idea to sketch our tan curve. So we're sketching it between, I'm going up to 450 here, so make sure that I cover my range of 60 to 420. So this is the graph of y equal tan x, remembering x is 2 theta plus 60. In order to solve tan 2 theta plus 60 is equal to 3 root 3, I'm going to do shift tan, so tan to the minus 1 of 3 root 3 on my calculator. And so making sure I'm in degrees on my calculator, if I do shift tan to the minus 1 of 3 root 3, close the brackets there, I get 79.1066 and so on. Now 79.1 is the first value given on the calculator, but I can find the next two values by adding 180 and adding 180 again. This gives me three values from this graph here of 79.1 and so on, 259.1 and so on, and 439.1 and so on. Now, remembering our range to be between 60 and 420, this value here, 439.1, is beyond our range, so we can ignore that value. And so the two values I need to solve for to find theta are 79.1 and so on, and 259.1. So subtracting 60 from these values and dividing by 2 gives me the two values of theta in our range of 0 to 180 of 9.6 and 99.6. And that's to one decimal place as requested in the question.